Hi, Sabrina. So, adding and subtracting radicals. In our notes, the first example I had done was if you had something like 5 radical 3 plus the square root of 27. So if you have something like this, it looks like they can't be combined, but you would need to simplify the square root of 27 because 9 goes in, and 9 is a perfect square. So you take the square root of 9, which is 3, so this is really 3 radical 3. So when you add 5 radical 3 plus 3 radical 3, you end up with 8 radical 3. You add the coefficients on the outside, and you keep the radical that's the same. Your question on your email was 2 times the square root of 6 minus 2 times the square root of 24, which is kind of the same thing. You look to simplify them if you can. 2 radical 6 can't be simplified, so I'm going to bring it down. The square root of 24 contains 4 as a perfect square, so the square root of 4 is 2. That comes out, and you have minus 4 times the square root of 6. And now you subtract the numbers on the outside, the coefficients. 2 minus 4 is going to give you negative 2, and then you bring down the radical 6. Okay, let's see. Another example, I'll do one more like this, would be, let me slide this down. Example 3, if you had the square root of 18 plus 2 radical 3 minus the square root of 8, and I did one like this in your notes also, you would simplify them as much as you can. So the square root of 18 contains 9, so the square root of 9 comes out, that's 3 radical 2. Bring down the 2 radical 3, and the square root of 8 can be simplified because 4 goes in. The square root of 4 is 2, so that's really minus 2 radical 2. And then you look through to see which ones are like terms. 3 radical 2 and 2 radical 2 are like terms because they both have the square root of 2. You subtract the coefficients. 3 minus 2 is 1 radical 2, but we don't write the 1, we just write radical 2. And then bring down the plus 2 radical 3. So your answer is a binomial. Okay, and you had examples like this in your notes. Multiplying radicals. Let me slide this. So for multiplying, let me just, let's see. One example I had done with you is I had done the square root of 8 times the square root of 12. Here's another one, 4 times the square root of 6 times 7 times the square root of 2. You would multiply outside numbers times outside numbers and numbers under the radical times numbers under the radical. So I'll do those in red. So the 4 times 7 is 28, and square root of 6 times square root of 2 is square root of 12. So you actually multiply those radicals. And then you look to see if you can simplify. The square root of 12 contains 4. So any perfect squares that can be removed, you do that. Square root of 4 is 2, so the 2 comes out and multiplies by the 28. And actually, I remember doing this on your notes now, so you're going to end up with 56 times the square root of 2. Maybe you'll see distributive, before distributive property, also when you're squaring. So let's say you had, example 2, 2 radical 3 squared. That means 2 radical 3 times itself, times 2 radical 3. So you're going to multiply again outside numbers together, and then the numbers under the radical symbol together. So 2 times 2 is 4, and the square root of 3 times the square root of 3 is the square root of 9. But for this type of problem, whenever you multiply the same square root times itself, it ends up producing a perfect square. So you can take its square root. The square root of 9 is 3, just a regular 3. So the answer is 4 times 3, which is 12, like a regular old 12. There's no radical in your answer. And then you might see like the distributive property. I had gone over in your notes also some examples that look like the distributive property. I'm having trouble scrolling down on this, so I'll keep making a mess up top. But distributive property, you could have like 3 times the square root of 2 plus 9 radical 3. The 3 is rational. It doesn't have a square root, so it's going to multiply by the outside numbers. So in the square root of 2, it multiplies by the invisible 1 on the outside. So you get 3 radical 2. And then when you distribute with the second term, you multiply only by the 9. So it'd be 3 times 9 is 27, plus 27 radical 3. And then you look to see if you could simplify the radicals. You can't, so this binomial is your answer. Another one that has radicals on everything would be like 3 radical 2 times, let's say 5 radical 30 minus 9 radical 2 plus 3 radical 6. So when I distribute, I have the 3 times the 5, which is 15, and then radical 2 times radical 30 is radical 60, minus 3 times the 9 is 27, and then radical 2 times radical 2 is square root of 4, right? That's going to be a perfect square. I'm going to simplify that. And then 3 times 3 is 9, and square root of 2 times square root of 6 is square root of 12. Now everything can be simplified. 60 contains a perfect square. It contains a perfect square of 4. 4 times 15 is 60. So square root of 4 is 2. The 2 comes out, so this becomes 30 radical 15. The square root of 4, like I said before, that's a perfect square. So the square root of 4 is just 2. So 2 times the 27 is going to be 54, just a regular 54. There's no more radical because this was all rational. It's a perfect square. And then plus, and 12 contains a perfect square, 4. So 4 times 3, square root of 4 is 2. 2 times 9 is 18. So I have 18 radical 3. And this doesn't contain any like terms because you have radical 3, radical 15, and then a constant 54 that doesn't have a radical. So your final answer is just those 3 terms. It's a trinomial. Okay, let me know if there's any other specific examples you want me to go over, like from your homework. You asked about equations. We didn't solve any equations or anything. So there were a lot of problems on your homework that I didn't assign because we didn't learn those topics. So just let me know which ones you want me to go over. Okay, thanks.